Remember that we're following the integration what to do and when flowcharts when answering integration questions. Also, remember that you've got your trigonometric formulae in the formula book should you need them. First question. We're integrating 6e to the 2x plus 1. We know that e to the 2x plus 1 is going to integrate to be e to the 2x plus 1. So we've got 6 of those, but because of the 2 on the inside there, we do need to divide by 2 because of the reverse chain rule. And the 6 divided by 2 is 3. So our answer is going to be 3e to the 2x plus 1 plus c. Question 2. We've got sine 3x. We know that sine is going to integrate to be minus cos. But because of the 3 on the inside there, we need to divide by 3 because of the reverse chain rule. So we'll have minus 1/3 cos 3x plus c. Next, we've got the integral of 2 minus 1 over x squared. First, I'm going to rewrite this by expanding the brackets. So we've got 2 squared, which is 4. Then we've got 2 times minus 1 over x, which is minus 2 over x. Double that, and we get minus 4 over x. And then we've got the minus 1 over x times minus 1 over x, which will be plus 1 over x squared. Now I've expanded the brackets, each of these terms can individually be integrated pretty easily. The 4 will integrate to be 4x. The minus 4 over x will integrate to be minus 4 ln x. And in order to integrate the 1 over x squared, let's rewrite that with a negative power. So that's the same thing as x to the power minus 2. So add 1 to the power, divide by the new power, and we'll get minus x to the power minus 1. Or minus 1 over x if you prefer. Moving on to question 4. We've got the integral from a to 2a of t plus 1 over t dt is equal to ln 7. We need to show that a is equal to ln k, where k is a constant to be found. So in order to do this integral, I'm first going to rewrite this as t over t plus 1 over t. I'm just dividing both terms on my numerator by t. I've got the t divided by t, and I've got the 1 divided by t. Well, t divided by t is just going to be 1. So let's simplify that. And now both of these are going to integrate easily. The 1 will integrate to be t. The 1 over t will integrate to be ln t. And I can substitute my limits in. So substituting the 2a in first, we'll get 2a plus ln 2a. Now substituting the lower limit of a in. And remember that we were told that this whole result was equal to ln 7. So we're subtracting the a, we're subtracting the ln a. If we collect up like terms here, we've got the 2a minus a, which is a, plus then we've got the ln 2a minus ln a. We can use laws of logarithms to simplify that as ln of 2a divided by a. And now we can see that those a's are going to cancel out and just be ln 2 equals the ln 7. I'll subtract ln 2 from both sides to get ln 7 minus ln 2, which is the same as ln 7 over 2. And that is my value of a. A is equal to ln 7 over 2, which is in the form required, where k is 7 over 2. Question 5. I'm going to add 1 to the power, so the power is now going to become 5 over 2. I'm going to divide by the new power, so divide by 5 over 2 is the same thing as timesing by 2/5. And also, because of the 2 on the inside here, I need to divide by 2. The half of the 2/5 is 1/5. And then I've got the 2x minus 1 to the power of 5 over 2, and my plus c is already there. So that is question 5 then. Question 6. First, we're going to rewrite this with a negative power. So I'm going to rewrite it as 3 lots of 5x minus 1 to the power of minus 1/2. We'll add 1 to the power. So minus 1/2 plus 1 is positive 1/2. We're then going to divide by the new power. So dividing by 1/2 is the same thing as timesing by 2. So I'm timesing that 3 by 2 to get 6. We then also need to divide by 5 because of the reverse chain rule. And so my answer is 6/5 of 5x minus 1 to the power of 1/2 plus c.